Now for the volume using double integral in polar coordinates. We already figured out that if you do a double integral of a function over the domain, it captures the volume under the surface over this domain, right? I want to use this fact to calculate the area of a sphere. So here's a sphere. Not the area, sorry, volume of a sphere. Now, does anyone know the formula for the volume of a sphere? 4/3 pi r cubed. That's the formula for the volume of a sphere, which you learned in high school or some time, and you were using it even in SAT, but you never got to know why, right? But today we can actually calculate and verify this is true. Now, it's enough for us to verify that the unit sphere, meaning that the sphere with radius 1, has the volume of 4/3 pi, because once we establish that, then any radius can be just multiplied by r cubed, because if the ratio of length is 1 to r, then the volume ratio will be 1 to r cubed. So you just multiply r cubed and you get the formula. So what I want to establish now is to actually get the volume of the sphere equal to 4/3 pi. Well, volume of the unit sphere to be equal to 4/3 pi. So let's try to calculate this. All right. The first thing is I want to cut this sphere in half. Oh, no. I don't want to do that first. I want to first think about the formula for this sphere. The formula for the sphere, well, formula for the circle is x squared plus y squared equal to 1, right? And the reason that this gives you a circle in 2D is because this basically says square root of this is 1, and this is the distance from the origin, and you're basically collecting all the points on the plane, which has distance 1 from the origin, so you get this circle, right? In 3D, all you have to do is put a z squared there, and this left side, if you take the square root both sides, that means it's the distance from the origin to this point x comma y comma z. And to say that that's equal to 1, that just means you're collecting all the points that's 1 away from the origin, so you get what? You get a sphere in 3D. So this is the equation for the sphere. Now let's solve this for z to get a function of x and y. So you take the square root, you get plus or minus square root of 1 minus x squared minus y squared. And you get one function that's positive, another function that's negative, and each of those correspond to the top hemisphere and bottom hemisphere. So the plus one will be the top hemisphere, and minus will be the bottom hemisphere. And what we want to do is we just want to do the calculation in the following way. If we want the volume of this sphere, we can just take the twice of the volume of the top hemisphere, right? And because the top hemisphere's equation is square root of 1 minus x squared minus y squared, if I take this function and integrate over this circle, that's here, this circle here, if I integrate over this circle, then we get what? We get the volume of the sphere, right? So we get, if we do this, we get the volume of the sphere. Okay. Now, this calculation is actually quite hard to do if we didn't have the polar coordinates. So just to convince you that it's really hard to do it in polar coordinates, don't write this down if you're taking notes. I just want to demonstrate how hard it is. See, what does this mean? That's a unit circle. See, the circle that's trapped here, that has radius 1, so it's a unit circle, right? This equation is the top half is y equals to square root of 1 minus x squared. The bottom half is y equal to negative square root of 1 minus x squared, right? And if you choose to paint upwards, then the integral that you have to do is twice of integral of this 1 minus x squared minus y squared. If I choose dy dx, it goes from this bottom half and it ends up there, right? So it's negative square root of 1 minus x squared to positive square root of 1 minus x squared. And then your x goes from negative 1 to 1, so it's from negative 1 to 1. So that's the integral that you have to do. But already, isn't this really hard? How do you integrate this with respect to y? I don't know how to do it. Yeah. It's quite hard. Okay? You don't want to do it this way. Okay? Rather, what you want to do is get rid of all this, go back, and I want to rewrite this in terms of r dr d theta, meaning that I have to express this as r dr d theta. How do you do that? Let's see. First, 1 minus x squared minus y squared is 1 minus x squared plus y squared. And I know what this is in terms of r. What is that?
1
No?
r squared.
R squared. See, the formula was r is
Yeah.
equal to square root of x squared plus y squared, right? So if you square both sides, we get that r squared is this thing. Right? So here's what we get. We get square root of 1 minus r squared. We just figured out that this thing inside is 1 minus r squared. dA is r dr d theta. And now we have to represent this circle, the unit circle, in polar coordinates, which is extremely easy. How do you do it? If you have the unit circle in polar coordinates and you're trying to paint this radially, where does your paintbrush begin? At 0. Where does it end? 1. Right? So you start at 0, you end at 1. Right? How about your angles? It goes from 0 to pi. Right? So it goes from 0 to pi. So that's the integral. And that's a lot easier because now you can take the u substitution with u being this, and this r will vanish because of the u substitution. So let me show you how. Set u as 1 minus r squared, then du is negative 2r dr, so that if you solve for dr, dr is negative 1 over 2r du. Okay? And now using that, let's rewrite this integral using the u substitution. It's twice 0 to 2 pi. Oh, by the way, when r is 0, what's the value of u? If you plug in 0 into r, what's the value of u? 1. When r is 1, what's the value of u? 0. You have to change the bounds. Don't forget that. Okay. And square root of, we decided to call this thing inside the square root as u times r, and then dr is now represented as negative 1 over 2r du. D theta is still out there. And now it's good because r is canceled. And then you can also use this trick of using minus to switch these two. Have you done this in Calc 2?
Yeah.
You can use the minus to switch the bounds. Okay? And then also 1/2 can be canceled with this 2. So let's see what you get after that. You just have 0 to 2 pi. 2 is canceled with 1/2, so that 1/2 is gone. Minus is used to switch these two, so it's 0 to 1. That's gone. And all you have to do is you integrate u to the 1/2 power. Square root of u is u to the 1/2 power, right? And du, d theta. And now you have to integrate u to the 1/2 power. What is that? The power rule. Add 1 to the exponent, which is 3 over 2. Put the reciprocal of that number, which is 2 over 3. D theta. Oh, no, sorry. And you have to plug in the bounds times d theta. And then when you plug in 1, it's 1. When you plug in 0, you get 0. So you end up with integral from 0 to 2 pi of 2/3 d theta. We're almost there.
What'd you do with the 2?
Oh, 2 and 1/2 canceled.
Oh, okay.
This 2 and 1/2 canceled. Minus was gone because I switched these two around, okay? And then, if you integrate, that's 2/3 of theta. You're plugging in 2 pi and 0. When you plug in 2 pi, you get 2 times 2 pi, 4 pi over 3. That's it. You got the result. Right? We verify that the volume is 4 over 3 pi, and that just verifies what we have known all along.
Yeah, that's correct.
Okay? Is that cool? Nice?
Really?
No?